Welcome everyone. I would like to present to you our machine learning based identification and classification of ocean eddies as part of the EDDI project that is funded by the DFG and that I'm working on in the remote sensing group together with these people from the satellite geodesy group, all from Uni Bonn. First, I would like to shortly explain to you what eddies are and why they are important. Eddies are considered to be the weather of the ocean. They are these circular currents that can have diameters as large as 10 to 500 kilometers. They are caused by baroclinic instability due to horizontal density differences or landmass obstacles. Their gyrating motion leads to a number of significant effects in hydrology, for example the poleward heat transport, or in marine biology, for example the upwelling of nutrients. But can we even detect eddies? Or are they too small or too frequently for the satellites to observe? The problem is that a satellite can only observe the same surface point every so often and can only be so close to the surface. This leads to the problem that the spatial or temporal resolution of what we can observe and then infer is limited, and maybe beyond our desired temporal and spatial scales, as we can see here. Eddies are actually touching this boundary, and indeed we are able to detect the largest ones. This is because of recent advancements in satellite oceanography. Those lead to a number of observations that, together with detecting algorithms, are able to detect eddies. For example, with satellite altimetry, we can observe sea level anomalies that gives the information about the location of an eddy. But as illustrated here, there's a lot more that we can learn about eddies if we push the borders a little more. But how can we do this? For that challenge, previous works, such as the EDDINet, are using convolutional neural networks, or CNNs, on 2D grid maps, for example of sea level anomaly data, short SLA data. In our case, we use gridded SLA data from the Copernicus Marine Environment Monitoring Service, or short CMEMS, from the year 2017. And is labeled with the help of the HiEddyTracker library for reference data. With that, we can infer a semantic map of cyclonic and anticyclonic eddies. But it only uses 2D grid maps of sea level anomalies in which the gridding process loses valuable information on the eddies. It would be favorable to use data products that don't suffer such information losses, such as ground tracks from a long track multi-mission altimetry data. And this is an issue where our project can come in, because one of our many research questions is, how can we base automated eddy identification and classification on ground track data using sophisticated deep learning techniques? We approach this question with the so-called transformer architecture. This is a novel neural network and became popular in recent years in the field of computer vision. It can utilize its intrinsic context of the data in a positional encoding to infer our desired product. In our case, this would be the semantics such as cyclonic and anticyclonic eddies on that ground track. We call our transformer architecture TEDDY, and the input data consists of SLA ground tracks together with its coordinates and timestamps that is used for the positional encoding to represent its spatio-temporal context in the network. As a result, TEDDY is able to infer semantics from ground track data with higher scores than a convolutional neural network on the same input data. Interestingly, for us the opposite is happening if we use 2D grid map data. There, only the CNN achieves state-of-the-art results with the same input data. So the very different architectures of convolutional neural networks and transformers show different strengths, considering the input data of either SLA grids or ground track observations. In the EDDI project, we can use that in the future to utilize multimodal architectures in which we can use the advantages of both in order to detect eddies even more accurately. For more on our project, I recommend to you the presentation of Adili that will take place here at the EGU tomorrow afternoon. Thank you for your attention.